You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine waking up, right, and finding out your digital assistant didn't just remind you about that persistent bug in your software project.
Right, like it usually does.
Yeah, exactly. Instead, it stayed up all night, cloned your entire code base, figured out the logic error, rewrote the authentication flow, pushed the update, and then even tested it on your live website.
Which is wild to even think about.
It is. But, I mean, as of late June 2026, that is no longer science fiction. We are crossing a massive, massive threshold right now.
We really are. We are moving definitively from artificial intelligence that just, talk to you into artificial intelligence that acts on your behalf.
Yes.
If you look at the sheer volume of research papers, the product launches, the massive funding rounds dropping just this week, the through line is impossible to ignore.
It's everywhere.
Yeah. We are witnessing the birth of agent-scale infrastructure. And the race is basically on to build the memory, the security, and the physical hardware to run these autonomous agents before the financial realities of the whole industry just collapse under their own weight.
Okay, let's unpack this. Because there is a staggering amount of news to get through today. I mean, we have everything from multi-billion-dollar compute wars to a genuinely bizarre pivot by an AI company into medical scanning spas.
Yeah, that one is definitely a left turn.
Totally. But we have to start with the core engines driving this shift because the software models themselves are getting these astronomical upgrades. ZAI just launched GLM 5.2, boasting a 1 million token context window.
Which is huge.
Right. And then OpenAI is rolling out GPT 5.6 next week with a 1.5 million token context window.
Yeah, and to really understand what a 1.5 million token window actually means, you have to kind of move past the idea of just feeding a model a really long PDF.
Right, it's not just a big reading assignment anymore.
Exactly. We are talking about short-term working memory. 1.5 million tokens means you can load the entire front-end code, the back-end architecture, the database schema, and all the internal documentation of a massive software application into the AI's brain simultaneously.
Oh, wow.
Yeah, it sees the entire blueprint of the house at once rather than looking at it brick by brick.
So it's like we're moving from a really smart typewriter to a ghostwriter who also knows how to operate the printing press and drive the delivery truck.
That's a great way to put it.
Because previously you'd paste a single function into a chat box and just ask the AI to optimize it. But now you point these models at sprawling, interconnected code bases and give them a high-level directive. And they aren't just reading the code, right? They are interacting with the end product.
Yeah, and that interactive capability is where OpenAI's Codex update really comes in, because they just integrated support for the Chrome DevTools Protocol, or CDP.
Which means the AI is literally opening a browser window.
Yes. It acts exactly like a human web developer. CDP allows the AI to access the live Chrome browser, monitor network requests, profile how JavaScript is executing in real time, and then dynamically rewrite the website's code based on what it sees breaking on the page.
That is insane.
It navigates the live web, just clicking and inspecting elements.
Though I did notice in the source material that this specific feature is heavily geo-restricted.
Right, yeah.
They've completely excluded the European Economic Area, the UK, and Switzerland.
Yeah, well, regulators in those regions are clearly uneasy about an automated intelligence actively manipulating live web environments.
I mean, understandably so.
Absolutely. When an AI can autonomously traverse the web and inject code, the potential for unintended consequences or malicious application, it just skyrockets.
Right. So if we have AI rewriting the live web via Chrome, that totally breaks how developers currently work together. You can't have an AI doing the work of 10 engineers, but waiting for a human to, manually approve every single comma on a platform like GitHub.
No, you just become a bottleneck.
Exactly. The workspace itself has to evolve, which brings up one of the most fascinating distinctions in our sources today, cursor origin.
Yeah, cursor origin is a big deal because traditional version control systems like GitHub were fundamentally built for human-scale development. The assumption is sequential, right? A human writes a feature, requests a review from another human, and then merges it into the main project. But Cursor Origin is attempting to build the first truly agent-native environment. It assumes you might have a dozen AI agents working simultaneously.
Which requires a completely different mechanism for managing code. Like, if 10 agents are working at once, they have to parallel clone the repository, branch off to try different solutions, and then commit their changes.
Yeah.
The source mentioned rebasing, which, for anyone outside of software engineering is essentially taking a whole timeline of code changes and seamlessly splicing it onto another timeline without breaking the history.
Exactly.
And Origin is built assuming AI will be doing this constantly, fixing each other's merge conflicts at machine speed.
And the visual interfaces are adapting to this speed as well. Mistral AI is moving away from the standard chat interface by adding dedicated code and APPS sections to their Vibe platform. And Claude Code introduced these shareable artifacts. So instead of reading a text summary of what the AI coded, it spins up a live visual web page where you can interact with the interface the AI just built. I mean, the chat box is literally transforming into a dynamic software factory.
But, and this is a big but, this introduces a massive logical bottleneck.
How so?
Well, if you have agents running around branching timelines of code, profiling live websites, and building applications, they cannot start with amnesia every time you open a new window.
Right, of course.
If they're taking action, they need to remember what they're doing.
Yeah, and what's fascinating here is this shift from temporary chat history to persistent memory architecture. Perplexity just rolled out Perplexity Brain.
Which is a great name, honestly.
It is. And this isn't just saving a transcript of your previous conversations. It actively builds a persistent context graph.
Okay, so think of a context graph like a detective stringboard in a crime movie.
Oh, I like that.
Yeah, it doesn't just put files in a folder. It draws a mathematical string between, say, the PDF you uploaded on Tuesday, the meeting notes from Thursday, and the code you wrote on Friday.
Right, it connects the dots.
Exactly. It maps the relationship so it can infer why you made a decision. Imagine how much time you'd save if your digital assistant remembered the subtext of a project from 3 months ago and applied it to the task you assigned it this morning.
It would be incredible. However, that level of deep, interconnected memory introduces a pretty severe privacy vulnerability.
Ah, yeah, the Mosaic Leaks paper.
Exactly. ServiceNow published this research examining deep research agents. And these are the agents designed to take your private internal company documents and augment them by searching the open web for up-to-date context.
Right, so if the AI is trying to solve a problem with a highly confidential, unannounced product, the way it searches Google to find that solution could be a massive liability.
It's a huge liability. The findings were actually really alarming. In normal operation, these agents were leaking sensitive, private information into their external search queries about 34% of the time.
That is wild.
Yeah. If it needs to solve an issue with an unannounced corporate merger, it might literally type the names of the two merging companies into a public search engine to find financial data.
Wow. But the researchers did propose a mechanism to fix this called PADR.
Yes, PADR.
Yeah.
And it operates like an internal mathematical editor. Before the AI is allowed to send a query out to the open web, the system evaluates the proposed search string against the private documents.
Making sure it's safe.
Exactly. It fundamentally trains the agent by issuing a negative reward, so a mathematical penalty, if it constructs a query containing private strings of text. By heavily rewarding safe query construction internally, they reduce the information leakage rate from 34% down to 9.9%.
Oh, wow, that's a big drop.
Yeah, and all without degrading the agent's ability to actually find the right answers.
That's a really great software safeguard. But I kind of have to push back on another security document in our stack.
Okay, which one?
We have Google's AI Control Roadmap, which outlines their framework for advanced AI security. And the source explicitly states that Google considers its own internal agents as potentially misaligned.
Right.
I mean, if the creators of the technology are operating under the assumption that their own AI might go rogue inside their company servers, how safe is the end consumer?
It's a fair question. But Google is practicing what cybersecurity experts call defense in depth. They are admitting that perfect alignment, the idea that an AI will perfectly understand and obey human intent 100% of the time, is just a mathematically unrealistic assumption right now.
Makes sense.
Therefore, they're building system-level security and sandboxing to contain the model when it inevitably misunderstands a goal or attempts an unauthorized action.
Okay, so it's less like locking a rebellious employee in a secure room and more like giving them a dummy terminal. The AI thinks it's accessing the main server. It thinks it's executing commands and rewriting databases, but it's actually playing in a simulated bubble. If it tries to delete critical infrastructure, it's only deleting a mirage.
Right, and that containment strategy is vital. But OpenAI published research this week taking a slightly different approach with beneficial reinforcement learning.
Okay.
Instead of just trapping the AI, they're trying to fundamentally alter its baseline behavior. They found that by continuously training models on realistic scenarios that reward helpful, harmless traits, they can deeply entrench specific personas.
Interesting.
Yeah, this isn't just giving the AI a rule book, it's more like building muscle memory. These beneficial personas actually persist and resist breaking character even under intense adversarial pressure or, deliberate jailbreak attempts.
Wow. So we are building context graphs so they remember our workflows, dummy terminal sandboxes to contain them when they mess up, and deep-seated personas so their default state is helpful.
Yeah.
But everything we've talked about so far is happening in the cloud. The sources show this intelligence is violently breaking out of the server farm and into the physical world.
Yes, the hardware side is catching up.
Right. Let's look at what's happening on the devices in our pockets. Google just introduced the Model Context Protocol, or MCP, for Android 17. So what does this all mean?
Well, MCP fundamentally rewires the operating system. It allows the individual apps on your phone to expose their internal tools and functions as headless services.
Headless meaning no visual interface.
Exactly. An on-device AI agent can discover these tools and execute them directly without ever opening the graphical interface of the app.
Wait, so what does this all mean for the user? Does this mean the app interface is effectively dead?
Over time, yes. I mean, right now, you open a ride-sharing app, tap the map, confirm the ride, open your calendar to check your destination, and then open a messaging app to tell someone you'll be late.
All right, lots of tapping.
With MCP, you just tell your phone's agent, "Get me to my next meeting." The agent silently pings the calendar API for the location, pings the ride-sharing API to book the car, and pings the messaging API to send the text.
Just entirely in the background.
Completely invisible.
Man, if the AI is orchestrating all the apps invisibly in the background, the physical design of our hardware is going to pivot entirely. You don't need a glowing 6-inch rectangle of glass in your pocket if you never have to actually tap a button.
And Qualcomm is betting their entire future on that exact premise. They are currently developing over 40 different AI wearable devices. 40. They just announced the Snapdragon Reality Elite, which is a silicon chip explicitly designed for mixed reality glasses. They're aggressively positioning themselves to be the foundational hardware layer for whatever wearable interface eventually replaces the smartphone.
But bridging the digital and physical world isn't just about booking Ubers through a pair of smart glasses. Our stack includes a research paper on Quinn Robot World.
Yeah, that one is fascinating.
It's wild. This is a language-conditioned video world model. It uses natural language as a single, unified interface for physical robotics, navigation, and even driving. And I kind of have to question the sanity of this.
Oh.
Well, is it really safe to let a language model, which generates responses based on probabilities, drive a real car?
Well, the researchers are attempting to prove that a model can actually understand the physics and context of a video.
Yeah.
Like how a car's momentum carries it down a street, or how a robotic arm needs to adjust its grip on a fragile cup.
Okay.
If it understands the physical rules of the video it's generating, you can direct it with language. But you're right, translating the probabilistic, sometimes hallucinatory nature of a language model into the deterministic, zero margin for error reality of driving a 2-ton vehicle, that is an incredibly high-stakes gamble.
Speaking of high stakes and bridging the digital and physical, here's where it gets really interesting. Of all the developments in late June, this is easily the most unexpected pivot, Midjourney. The company famous for letting you type in a prompt to generate beautiful AI art is building a full-body ultrasonic medical scanner.
I know, it sounds completely absurd on the surface, but the underlying mechanism actually explains the leap perfectly.
Yeah.
Midjourney's image generation relies on diffusion models. And diffusion models work by taking random noise and gradually organizing it step by step until it forms a clear picture.
Right. And ultrasound machines basically bounce sound waves off your internal organs, which bounce back as incredibly noisy, messy acoustic data.
Precisely. So they are taking the exact same AI architecture that turns static into a digital painting and using it to turn noisy acoustic echoes into a hyper-detailed 3D scan of the human body.
That's brilliant.
They are mapping tissue down to a fraction of a millimeter. And because the AI is doing the heavy lifting of interpreting all that data, the entire scan takes just 60 seconds.
60 seconds. A traditional full-body MRI can easily take 60 to 90 minutes.
Exactly.
And Midjourney isn't just building the software, they are building physical spas to house these machines for customers.
But, and there's always a but rendering, a 3D ultrasound in 60 seconds, or running 10 parallel coding agents, or locally processing mixed reality on a wearable device. All of this requires A mind-bending amount of computational power.
So much compute.
Which brings us to the underlying tension threatening to tear this entire industry apart, the sheer cost of silicon.
Right. And NVIDIA is still completely dominating the infrastructure landscape. Their new Blackwell platform just absolutely crushed the MLPerf 6.0 training benchmarks. But to pull off those numbers, they were utilizing 8,192 GPUs simultaneously for a single training run.
Yeah, the energy and financial cost of that is just staggering.
But the monopoly is showing cracks. Google realized the massive commercial potential of their own internal hardware, their tensor processing units.
TPUs?
Exactly. They are now directly renting out computing power from their TPU AI data centers in New York to Anthropic. Google is actively offering an alternative to the NVIDIA ecosystem to capture some of that infrastructure revenue.
And we are seeing the raw costs of this compute fundamentally alter how these companies actually do business.
Yeah.
Think about how you pay for software right now. You pay a flat monthly subscription. But how do you bill a user when their AI agent spends 3 hours in the background pinging APIs and arguing with another AI agent to fix a bug while you are asleep?
You can't just charge $10 a month for that.
Exactly. Anthropic ran into this exact wall. They had to completely pause the token-based billing changes they had announced for their Claude Agent SDK just days before they went into effect.
Ouch.
Yeah, figuring out the unit economics of an agent doing complex, multi-step, open-ended tasks is proving incredibly difficult.
Meanwhile, OpenAI is aggressively pricing the upcoming GPT 5.6 specifically to undercut Anthropic and bleed them of market share.
Right.
They're really capitalizing on the fact that Anthropic is currently tangled in U.S. regulatory issues that are impacting the availability of their Claude Fable 5 model.
And this extreme volatility is polarizing the industry's top minds. We have two completely contrasting financial realities playing out simultaneously in our sources today.
Let's hear it.
On one hand, the mega funding is still flowing. China's DeepSeek just raised a massive $7.4 billion.
Wow, and the talent war is so cutthroat that DeepSeek strictly mandated to their new investors. No poaching our staff and no encouraging them to spin off rival startups.
But on the other side of the spectrum, prominent pioneers are issuing dire warnings. Yann LeCun, who is widely considered one of the foundational figures of modern AI, made some very sharp public comments regarding the financial fragility of these labs.
Now, to be clear to everyone listening, we are just impartially reporting the tension within the industry here. We're not taking a side on the rivalry. But yes, LeCun publicly called Elon Musk's XAI a failure.
Yeah, and his rationale was mechanical, not just personal. He pointed out that XAI is struggling to secure top-tier talent and is being forced to rent compute infrastructure to recover costs rather than owning their hardware destiny. LeCun used this to illustrate a broader warning for the entire sector. He's saying these AI labs are heavily subsidizing the cost of running these models just to gain users. He argues they must drastically increase their prices or ruthlessly cut their operational costs. Otherwise, the entire ecosystem risks a big bubble explosion.
And if the venture capital funding dries up before these agent-scale models figure out how to be undeniably profitable, the bubble pops, which perfectly explains the explosive growth of a parallel, cheaper market.
Exactly. Startups like Basin recently hit a $13 billion valuation by betting entirely on this impending cost crisis.
$13 billion?
Yeah. They are building the infrastructure for companies to run cheaper, smaller, open-source models, assuming the market will eventually reject the massive premiums charged by OpenAI and Anthropic.
And those smaller models are becoming incredibly capable, too. Weibo just released VibeThinker 3B. It has only 3 billion parameters.
Which is tiny by today's standards.
Right. Compared to the massive cloud models, a 3 billion parameter model is like a highly specialized pocket calculator. Yet it is putting up coding benchmark scores that match Claude Opus 4.5. It proves you might not need $1 billion supercomputer cluster just to run a highly effective agent.
If we connect this to the bigger picture, the trajectory of this week's news is profound. We started with software models with 1.5 million token memories acting as parallel ghostwriters in cursor origin, actively surfing the web via Chrome protocols.
Yeah.
We moved into how these agents are building persistent context graphs of our lives with Perplexity Brain and the mathematical safeguards required to keep them from leaking our private data to the public internet.
Then we tracked the leap into the physical world. Android redesigning its entire architecture so agents can control apps invisibly. Qualcomm building the silicon for a post-smartphone world, and diffusion models powering 60-second medical scanners.
And finally, we examined the fragile, high-stakes economics keeping the lights on. The billions poured into GPU clusters, the struggle to figure out how to bill for autonomous labor, and the looming threat of a financial collapse if the infrastructure costs outpace the value these agents provide.
It is a staggering amount of transformation packed into a single week of news. But as we wrap up this deep dive, I want to leave you with one final thought to mull over. Our sources today showed us AI building AI in parallel code bases, and AI orchestrating actions across the live web and physical devices in the background. If these agents soon have perfect memory across all of your past projects, the security clearance to access your files, and the physical wearable hardware to act on them autonomously, the bottleneck in the future won't be the technology. It will be you. Think about your daily workflow right now. At what point do you become the slowest, most inefficient agent in your own life? And how will you adapt to your career and your daily habits when the AI isn't waiting for a command from you, but is actually tapping its digital foot, waiting for you to catch up to the decisions it has already made?
That's a lot to think about.
It really is.
All right.
Thank you for joining us on this deep dive. Keep questioning the rapid changes around you, and we'll see you next time.
Spoken Tech for your ears.